Okay, we have earlier done you know, some functions with Excel, right? So we used a function for sum. It was in the exam as well, right? What this will do, equal sum bracket a1 colon a10. What it will do, take a sum from a1 to a10. Okay, so colon is representing a series, right? Take continuous series from a1 to a10, all of them. Okay, same is a function for colon in MATLAB as well. So when you use a colon, it means everything in that series. Okay, so some of the examples are given here. For example, if you say t equals 1 to 5, 1 colon 5, it means what? T is a vector which has all numbers from 1 to 5. So instead of writing t equals bracket 1 2 3 4 5, I just write t equals 1 colon 5. Okay, just like we used it here. So colon represents, take everything from 1 to that number. Okay, and yeah, you can use another colon separator to give it an interval. So I want the numbers to be assigned from 1 to 5, but not with an interval of 1. So after 1, I don't want 2, I want 1.5. So you can use the second example then. So first number t equals to 1, which is the first number in the series. Then colon 0.5. What is 0.5? The interval. So after 1, take interval of 0.5. Then interval of 0.5. Then interval of 0.5 until you reach the last number. Okay. What is the last number? 3. Okay. So this last example will create a vector from 1 to 3, but with an interval of 0.5. Clear? You can also use a negative increment. Instead of having plus 0.5, it can be minus 0.5 as well. But then the sequence of numbers should also change. You cannot say 1 colon minus 0.1 and 3. From 1, you cannot go to 3 with a negative interval, right? So it will be 3 colon minus 0.1 and then 1. Okay, so sequence should change. Okay, the first number should always be the first number you want, the first number. So if it's a negative interval, then the first number should be the highest one, right? Then it will go to the lowest one. Okay, so keep it in mind. Okay, you can also use colon to call the numbers from the matrix. Okay, just like we did right here. So I was calling specific elements, right? I was mentioning take element number 2, element number 3, element number 4. Now let's say I want all elements in the second row. So second row has 10 elements. I want all of them. So I can write it like this. One by one mention element number, or I can use this statement. A bracket 2 comma column. Column means what? All columns of row 2. Okay. Now let's say you want all elements from second column, not second row. This is for second row. First number is row, and for the column I am saying all elements. Now let's say I want all elements from second column. So column number is 2, row all rows from column number 2. So how do I write it? How will I write it? Look at I. Where is I? What I? We are discussing colon here. Yeah, okay. So it will be, here it is 2 comma colon, then it will be colon comma 2. Okay, so colon means all elements, you know. So if you are using it as the row number, instead of the row number, if you are putting a colon, it means take all rows. Okay, if you are using it as a column number, that means take all columns. Okay, clear or not? Okay, and then you can use it like this as well. You can see, so I want element number 2 to 4, element number 2 to 4 for matrix T. Same thing, this is 2 to 4, right? Element number 2, 3 and 4. Okay, so instead of writing it 2 and 3 and 4, I can write it like this, 2 colon 4. It means the same thing as this. And what did I tell you about the order? How will it count the numbers? Yeah, column wise, right? So the first number is the first number in the first column, second number is second number in the first column, and so on. Vertically, it will count vertically. You have to keep it in mind. Okay, you can use line space and log space commands to generate numbers in a sequence. Okay, so line space command, you will give 3 arguments, the first number x1, the second number x2, and n is the interval between them. x1 is the first number is the sequence, x2 is the last number of the sequence, and n is the interval between each number in the sequence. Okay, so if you use 0 first number, 1 as the second number, the last number, so it will create a sequence from 0 to 1. And how many elements it should create? 6 elements between 0 to 1. Okay, so 0 is one element, counting 0. X1 is counted and x2 is also counted. So out of 6, we already know the 2. We said create 6 elements, right? So from 6 elements, I am already giving him the first value, and I am also giving him the last value. Okay, so between the first and the last, now create 4 more, right? Total 6. So you can see it here. It goes from 0 and 0.2 and 0.4. Okay, you can count it. They are total 6. Okay, clear? Any questions? Okay, log space will also do the same thing, but it will create the numbers in the interval of 10. Okay, log has a base of 10, right? Log has a base of 10. So it will create numbers from x1 to x2, but the interval will be power 10. Okay, you can see the example here. From 1 to 2, create how many numbers? 4. Okay, first number is we already so the first number is 0.1, then 1, then 10, then 100. So you see each number is changing by power of 10. 0.1, 1, 10, 100. Okay, so each number will change by the power of 10. Okay, so this is the difference between. Can you try this? I just want to check something. Just try the same statement. Okay, now if you don't give the value of n here, it will automatically generate 50 elements. For log space command, if you don't give the n value, the third argument, if you don't give it, it will automatically generate 50 elements. And for the line space command, if you don't give the n argument, it will generate 100 elements, 100 points. Okay, so the default for n for line space is 100. For log space it is 50. Clear? Huh? Okay. So we can assign strings or text to variables as well, like we do for numbers. The command is very simple: a equals to something, b equals to something. Okay, but we have to use a single inverted comma, which you can see over here. So I want to assign the value of miles to f, so I will write f equals single comma miles comma closed, okay, and the second as well. And you can join them together. In Excel, if you remember, we were using AND symbol, concatenate, for joining two variables together in VBA programming. Here you can see we can join it as a matrix. So you can see X joins F and S. Okay, so let's say F is the first name, S is the second name. I want to join them together. I want to print them as one. So I can do it like this. Now, do you see the spacing between the first and the second name? There is a spacing, right? The spacing did not come automatically. Look at the value of f. So there is a space within the comma, okay? If you want to give the space, you have to give a space within the comma. Okay, a space is part of the string. Clear? If you want to write, it's a very long line, it's a very long statement which you are writing, and you want to assign it in one variable. Okay, so it is going from one line to the other. Okay, it is not fitting in one line. It will keep on going. If you keep on typing, it will keep on going in one line, but you will not see. You have to scroll right and left. Okay, so to avoid that, we can use 3 dots at the end of the line. So 3 dots means what? It is continued in the next line. And if you don't finish in the next line, give 3 dots again, come to the next line, and so on. Okay, but again you can see the brackets as well. So use brackets. Okay, and then when you finish one line but you want to continue in the next line in the same row, then you give 3 dots, and then you come to the next row and you continue. Now if I don't give the 3 dots, what will happen? I already told you in the last lecture. If I don't give these 3 dots and I come to the next line, what will happen? Now you can see here all the numbers are in one row, right? Look at the answer. A equals what? All numbers in one row. If I don't give the 3 dots, then so I write 1, 2, 3, 4, 5. Then I go to the next row and I write 6, 7, 8. Then how A will look like? Yeah, it will take 1, 2, 3, 4, 5 in one row and 6, 7, 8 in the next row. Okay, so 3 dot means same row. I'm writing in another line, but for the program it is one row. Okay, and it also works if you, instead of putting 3 dots at the end of the line, if you put it at the start of the next line, it also works. Okay, so you write 1, 2, 3, 4, 5, enter, and then you put 3 dots and then write 6, 7, 8. It will work in the same manner. Okay, so either you put 3 dots at the end of the line and continue the next line, or you put 3 dots at the start of the line when you are continuing from the previous. Clear? Okay. Okay, so if you use the square brackets, what they are calling as ellipsis. Okay, so ellipsis is the square bracket. Okay, so I told you if you are writing text, you have to put it in commas, right? Single commas. These single commas should be inside the brackets. Okay, and the 3 dots should not be part of the commas. Okay, so you can see here what they are doing. One square bracket, then a comma, the single quotation mark, then one statement. Now they want to go in the next line. For next line I will put 3 dots, right? But I will first close the quotation and then put 3 dots. Okay, you can see closed, quotation closed, then next line 3 dots and then another quotation starting. Got it? So the 3 dots and the bracket should not be part of the quotation marks. Clear? They should be outside. So if you want to divide it in different lines, each line will have a new starting of the quotation mark, ending of the quotation mark. Okay, and all this is inside the brackets, inside the ellipses, square brackets. Clear? We already know about them. We have used them in Excel for multiply, divide, and so on and so forth. Okay, here you can see the backward slash. They are saying it is used for left division. Left division applies to matrix. So if I want to divide two numbers, I will use the forward slash like we do normally. A upon 2, for example. A is a number, 2 is a number. Okay, so A forward slash 2. But let's say you want to do A upon B and both of them are matrices. Then I will use the backward slash. I will write it as A backward slash B. So this is showing the program, both of them are matrices. Okay, clear? In Excel you cannot divide two matrices. Okay, Excel does not have division for matrices. It only has multiplication and determinant and I think inverse. Okay. Okay. So whenever you use an operator, whenever you do some calculation, I told you MATLAB will perform it immediately. Okay, so when you say 2 into pi, it will give you the answer immediately like you do with the calculator. Okay, if you don't want to see the answer now, you use semicolon. Okay, you can see it over here. So here you can see a series of calculation and the answer is at the end. So y equals to something and I want the answer for y square. So y equals to something, colon, it will not show what is y, and then y square, no colon, so it will give me the answer immediately. And the default name for the answer is ANS. If you don't tell where to store the value of the answer, it will store it in ANS, default. Okay, we know that all the software have, all the calculation softwares have their priority rules, right? So when you say y equals minus 4 square, so what is the answer? Minus 16. But when you take the square of any number, negative number, it should become positive, right? So why didn't it become positive? Because we didn't use brackets. So what did it do? It took the square and then put the sign, so minus 16. You see the priority? The priority was what? The power. So it did the power first and then the sign. Okay. If you want to do the square with the sign, then put bracket, which you can see in the second example. Y equals within bracket minus 4 square. So now the minus is also squared. Okay, so you have to be intelligent on how to use the priority rules. Okay, otherwise you can see a very big mistake here. Minus 16 and plus 16, very big mistake, right? So any number, any negative number which you are squaring, or any number which you are squaring, or any number which you are taking the power, my advice is always put it in brackets, even if it is just a single number, just to avoid any confusion and problems. Okay, the calculations can also involve complex numbers. What did I tell you about complex numbers? Huh? Imaginary number is a part of complex number. What is the imaginary number? Iota. And what is the value of iota? Minus 1, minus 1 is minus 1. Square root of minus 1. Okay? Square root of minus 1. So, in the last lecture I showed you, you can create a complex number. Okay? So, you can see x is a complex number, okay, which has the value of 2 plus 4 iota. Okay, 2 plus 4 iota. And now you are multiplying this with any number. So, you can see how the complex numbers are multiplied as well. You cannot just multiply and add them. Huh? So, if I want to multiply this with 3, so 3 will be multiplied with the real part, which is 2. So, 3 into 2 is 6. And then 3 will be multiplied with the imaginary part. So, 3 into 4 is 12. And you can see in the answer, both parts are still there. 6 plus 12 iota. You cannot add them. You cannot say, okay, 6 plus 12 is 18. Okay, because with 12 we have an iota, imaginary part. Okay, clear? Okay. Similarly, you can do any calculation. The main thing to keep in mind is complex number. It will perform the calculation on each part separately. If you are doing a square, it will do the square of the real part and the imaginary part. If you are dividing, it will divide the number with the real part and the imaginary part. Okay? 1 upon x, 2 parts, x square, 2 parts, x plus y. So, x is imaginary number and y is x is a complex number, y is a real number. So, what happened? It was 16, huh? 16 is what? Real. No iota. So, what did it do? It added 16 to which number? 2 only. Because you cannot add real and imaginary. Huh? This is why we have complex. If you can add, then problem solved. Huh? If I can add real and imaginary, then x will be 6. Huh? Not 2 and 2 plus 4 iota. Okay. So, these are the things you have to keep in mind. Okay. And don't ask me where do we use complex numbers. I don't know. Mathematicians come with these things so that our lives are hell. Okay. Yes. So the main reason for coming up with this language or with this program is the calculations using or calculations for vectors and matrices. We have already seen in Excel we can only perform some of the calculations for matrices. Okay, but MATLAB gives us more options. In fact, MATLAB treats the matrices just like any variable. So you don't have to use any special command. If A is a single number or if A is a matrix, in MATLAB when we are performing any calculations, there is no special function for a single number and for a matrix. You can see the example over here. A is a vector and B is a vector, right? Which one of them is a column vector, which one of them is a row vector? Tell me. A is a row vector because every number is in one row. And what about B? It's a column vector. How do I know? Because of this single quotation mark in the end. Okay, it will make the row into column. It will transpose. Okay, so B is a column vector. Now, if I want to multiply A into B, A into B. If A is a single number, B is a single number, same command. A into B. Clear? Okay. So that's why it's very easy. You can see the answer over here. Okay, now what did we say that we can only multiply two vectors or two matrices when what happens? There's a condition, right? You cannot take one vector and multiply with another vector, or you cannot take one matrix and multiply by any matrix. There's a condition. What is the condition? It came in the exam as well. Number of columns first matrix equals number of rows second one. Now here you see in this example, the first matrix A has how many columns? 5 columns. Okay, and the second matrix B has 5 rows. That's why it can be multiplied. Okay, otherwise it will not be multiplied. So if you are doing B into A, then this is the answer. If you do A into B, answer is how much? 110. If you do B into A, answer is a whole matrix. This was a mistake which most of you made in the exam. You did A into B, but you did not do B into A. You had to check both. Huh? I gave you the solution. Okay. Okay, so these are some more examples. Okay, and you can see that in the first example, capital A, every row is, every row is separated by a semicolon. Okay, and so on. And I already told you MATLAB is case sensitive. So small a is different, capital A is different. You can store different values in them. And if you don't follow this rule, the condition, number of columns equal to number of rows, first and second matrix, then it will display an error message, and this is the error message. Okay. Now, as you are using these programs, VBA or MATLAB, try to focus on what is the error message. Okay, I'm telling you, it's for your own good. Okay, read the error message. In many cases, you know from the message what is my mistake. Otherwise, you will be doing trial and error. So in order to correct one mistake, it will take you 10 minutes. But if you know what the message is about, what the message is saying, you can correct your mistake in 1 minute, right? Okay. So if I get this, what is it showing? Matrix dimensions must agree. I know my mistake, right? I'm trying to multiply two matrices and their dimension is not up to my condition. Simple. Okay, clear? If you are not reading the message, you will keep on doing the same thing for 15 minutes and then you will say we don't have enough time. Same thing with VBA as well. When a message appears, an error message appears, it gives you a hint what is the problem. Okay, and in many cases we are making the same mistake again and again in different programs. Because of a habit or something, I keep on forgetting the small letter and the capital letter, maybe, so same message will appear. Okay, so if I know and I read the message, then I know my mistake in 1 second. Okay, so whenever you get an error message, at least read it one time before you start correcting. Okay, and in case of VBA, what you are using earlier with Excel, it gives you the message and it tells you where the mistake is, in which line. Okay, in which line the mistake is. Okay, so if you do A into A into A is A square, right? A into A is A square. So you can do it like this, or you can write A square, same thing. Okay, you can multiply, divide a scalar quantity with a vector quantity. So pi is a number, right? What's the value of pi? Still 1/6. 4 1 1 6 4 1 1 4 1 4. Okay. I remember when I asked you the last time, you said 1 6. Okay. 3.14. So it's a number, right? So whether you are dividing matrix A with a number, you don't have to use any special command. You just write it like this, but since it's one number, so what it will do, it will divide each element of A with this number separately. Okay. So A is whatever the value of A is, I think is here. So the first element of A is what? 1, right? So 1 divided by pi, then 2 divided by pi, then 3 divided by pi. Okay, just like this. Why? Because pi is a number. Pi is a single number. Okay, so it will take one element from the matrix and then it will do something with the scalar element by element, one number by one number. Okay. Yeah. Now let's say you don't want to do A square. Okay. A square is what? A multiplied by A. And we know when you are multiplying matrices, you do first row, first column, second row, something like this. Okay. But I don't want to do this. I just want to take each element from A and do the square, simple square. No matrix operation. I don't want to do matrix multiplication. So I will use a dot. After A, I will use a dot, single dot. Okay. So it means what? Don't do A into A. This means take each number from A and do a simple square. So the first number of A was 1, so square of 1. Second number of A was 2, so square of 2. Okay. So this is the answer which you see on the slide here. This is A dot square, and then you see A square. You see the difference? What is the first element here? 10, right? Oh, sorry, 30. And what is the first element here? 1. What is the second element here? 66. And second element here? 16. Okay. So dot will take each element and then do whatever you want to do. Okay. Clear? But if so, this is when you are squaring it or taking a square root or doing something like this, log of all numbers and so on. But if you say A multiplied by 2, no difference, because 2 is a number, right? 2 is a single number. It will not make any difference. Okay. Similarly, you want to take a cube, then A dot cube. Okay. So it will take each number from A and it will do the cube of each number separately, and the number will remain in its place. Okay. Any questions? Clear? Okay, now we will look at some of the built-in functions in MATLAB. Oh, so yes, built-in functions in MATLAB. We looked at the built-in functions in Excel as well, right? We are going in the same order. We also looked at some of the functions in the previous slides as well, right? Like the format is a built-in function, right? We use a pi is a built-in function. When you write pi, it gives you the value 3.14. Okay, and so on and so forth. Okay, so now we look at some other built-in functions. For example, the help log function. Okay, so it will tell you what is log. Good tip for the exam, right? You were asking me what to write in question number 3, right? Where I gave you the statement, I asked you explain it. It was question 3 or question 4? 4, right? you go to Excel, Excel gives you. You write the statement in Excel and you click on function, it gives you what the function is doing. Okay, so you just have to copy and paste. Same thing with help here. So there's a function in MATLAB. Somebody gave me a program, and in that program there's a function they used log, L-O-G. I don't know what the function is doing. So I can take the help from MATLAB. Okay, instead of searching online or on YouTube, which we like very much. So you will still search on YouTube, right? Whether it shows you or not, because we like watching YouTube, right? So you can use the help function. So help and the name of the function, any function, sine, cosine, pi, I was, what was I? Yeah, iota, right? We call it iota. So you don't know, there is a program in which there is a function and you don't know what the function is. So you use help and put the name of the function. Clear? So it will give you, you can see, it will give you all these things. See how detailed it is. Very detailed, right? It's a natural log, it takes this and so on and so forth. Okay? Very, and you can see it is also giving you any function which is similar to the function you asked. So you are using sine. So when you ask for help about sine, it will also give you what function to use for sine inverse. Okay? So good tool. Okay. Okay, if you want to see all the elementary functions, okay, which are in MATLAB, I don't know what it means. You can try it. Okay, try it. The first statement. Try it. Let us see what are the elementary functions. An option to do that. Okay. Now, with all these elementary functions which you see on your screen now, if you perform them on a matrix or a vector, it will be performed element by element. For example, they have given the example of log. So log is an elementary function. So when I see log of A, and A is a vector, so it will take each element from A and take its log one by one. Okay, and the value of the log will be stored in the proper place. So when it took the log of the first element, the answer is stored in the first element. Log of second element, the answer is stored in the second element. Okay, so you see here 0.06 is the log of 2, which is the first element of A, and 1.09 is the second element of log, which is the log of second element of A. Clear? So elementary functions are performed by default element by element. Okay, all the elementary functions which you see in your screen now, they are performed element by element. And then I already gave you, there are some functions, okay, mainly related to the power, which can be performed in a matrix fashion or element by element. I already gave this value, the example of square, right? You can do A square simply, it will do it matrix multiplication, and you can do A dot square and it will do element by element. Okay, so instead of doing a square, you can take a square root. A square root is power of what? Square root is power of 1 by 2, right? Square root is power of 1 by 2, right? Power of 1 by 2 or exponent, you want to take the power of exponent. Okay, so again you can do it in a matrix fashion. Okay, so here you can see here, so they are saying you can use you know the matrix M, the letter M, if you want to perform the function in matrix fashion. Okay, so in the first case, when you say square root of b, so sqrt is a function in MATLAB to take the square root. Okay, so when you say sqrt of b, it performs the function on b element by element. Like I said, default is do it element by element. Okay, but when you say sqrtm of b, it will perform the function in matrix fashion. Okay, clear? So now you can see the difference. When you say square root of b, it will take each element of b and take the square root, simple, and put it there. When you say square root m of b, so it is performing the square root of b using the matrix. Okay, so then you can see when you are obviously multiplying two numbers, and in matrix you have to multiply and add, right? You multiply and add, so you can get a negative answer as well. So whenever you get a negative in the square root, negative in the square root will become an imaginary number, iota. Okay, so this is why you see it. So if you want to perform an elementary function, cos, sine, square, exponent, in a matrix fashion, not element by element, then you have to use the letter m with it. So there is log of a and there is log m of a. There is square root of a, square root m of a, exponent of a and exponent m of a. Okay, so m with any elementary function can go. Okay, there are several functions you can use for rounding off the numbers. One of them is to use round. Okay, so round will do what? It will take all elements and round them to integers. Okay, you can see e has a decimal place. I want to convert it to integers, so you can see the answer over here. Okay, and you can see the rounding off is done to the nearest number. So 1.6 becomes 2 and 1.4 becomes 1. Rounding to the nearest number. 1.5 becomes 2. Okay, and not there. Anyways, so you can also use this one. Okay, so it will round the number or round the function to the nearest integer towards infinity. Okay, so e is the same matrix. So here you are using the round function, so it was just rounding to the nearest integer. Here it is rounding to the nearest number towards in infinity. Okay, so which number changed here? Sorry, so 1.6 minus 1.6 became minus 1. Why? Because minus 1 is closer to infinity, right? Okay, let me make it simple. It will round up. Simple, round up. Round up meaning what? Now you say round up of 1.6 is 2. Round up meaning round to the highest positive number, like towards the positive side, the highest number. So which one is higher, minus 1 or minus 2? Minus 1 is higher. Minus 2 is lower because it's minus. Okay, so ceiling will do to the greater number, round off to the greater number always. Okay, so between minus 2 and minus 1, the greater number is minus 1. Okay, between 0 and 1, the greater number is 1. Between 5 and 6, the greater number is 6. So whatever the decimal place is, it doesn't matter. It will take the greater number always. Okay. Floor function nearest integer towards minus infinity. So it will round off to the lower number. So it's the opposite of ceiling, huh? Floor is the opposite of ceiling, right? Ceiling is this one. In English, ceiling is the roof and floor is the floor. So they are opposite, right? Huh? So when you use the ceiling function, it will round off to the greater number. When you use the floor function, it will round off to the lower number. Okay. So between -1 and -2, lower number is -2 always. Okay. Whether it is 1.1, -1.1 or -1.9, doesn't matter. With floor, it will always do -2, and with ceiling, it always do -1. Okay. Okay. So you can perform special functions on the matrix itself, like summation, minimum, maximum, and so on and so forth. So what it will do, if you use sum f, it will take all elements of f and do the summation. Simple. All elements of f, doesn't matter how many rows, how many columns, doesn't matter. It will just take the summation of all of them. Clear? And similarly, you can use min, max, mean. Mean means it will take an average. It will take all elements of f and take an average. Okay. Mean. Product. Product means multiply. So it will multiply all elements of f. Okay. Sort. So it will take all elements of f and sort them in ascending order. Okay. So if 1 was the 10th element, now it will become the first element. Okay. Clear? And they have given the examples as well. So f is, you can see f here, 3, 5, 4, 6, 1, right? So 1 is the last element. When you sort it, it becomes a first element. Okay. And then 3, and whatever the elements are available, it will sort them. It will not put numbers by itself. So 2 is not there. So even after sorting, 2 does not appear, right? So it will take the existing elements and put them in order. Okay, it will not put the missing elements. Okay. So this is one example which I showed you in the first lecture. Okay, the velocity of a bungee jumper. He is jumping, he wants to kill himself, but for some reason he is not successful. So we have this equation for him. Okay. So so b is the velocity, g is the gravity, we know that, m is mass, cd is coefficient of drag for the air, and t is time, how long he was hanging from the wire. Okay. So you can use MATLAB to create a column vector which will check the values of v from 0 to 20 in steps of how much? A step of 2. Okay. So it will, you can use MATLAB to create this column where t is changing from 0 to 20. Okay, and the interval is 2, and it is so it will you can create a vector here. Okay, so the first value is 0, the last value is 20, and the interval between each value is 2. So we are using the column operator, right? I already told you. And why do we have this? To make it into a column vector, otherwise it will be a row vector. Okay, so it will create this column vector, you take it, you copy it in Excel, or you calculate the values using all of them. So it can be done. Okay, somebody gave you a program in which there is a vector t, Now you want to see how many elements are there in T. So you can use the function length. So length will give you how many elements are there in T. Got it? We had a similar function in Excel as well. Anybody remembers? Came in the exam as well. LEN, right? Okay. So same thing here. So we create a column vector T, okay, and then because gravity is a constant, mass is a constant, CD is a constant, so we assign their values. So T is a vector, remember T is a vector, and how many values in T? 11. Other values 1 1 1 1. Okay. Then I can use this equation to calculate the value of V for all values of T. So how many values of V then? 11. At every value of T it will create a value of V. Okay, so you have two vectors now. One vector you created simply doing the first statement, and then another vector simply doing the second equation. Clear? Try it. Create T and then calculate V. So T is from 0 to 20 and the interval is 2, and then you have the rest of the things here. Okay, using MATLAB, now keep the programs, okay, that's why we created the values. You can plot the values as well using the plot command. You can see it over here. So if you already created T and V, you can create a plot. Try it. The plot command. So you must already have the variables which you want to plot. So you already have T and V, only then this command will work. Okay, and it must have opened in a new window, right? The graph opens in a new window. Now can you tell me which value is on the x-axis and which value is on the y-axis? Which value is on the x-axis, which value is on the y-axis? T on the x-axis. And where did we tell it to the program that put T on the x-axis? It was the first, okay. So when you are plotting, the first variable you mention goes on the x-axis, the second one goes on the y-axis. So you have to keep the order in mind. And you can right click on the graph and you can copy it and paste it in Word or whatever. Okay, just if you just do the right click, it will show you the options. Okay, options are, I think you can print it as well. There's an option to print the graph, to copy the graph, and so on. Clear? We know with graphs we need more information, right? Like I was asking, what variable is on the x-axis, what variable on the y-axis. So let's suppose you printed this graph and you gave it to someone. Now how would that person know what is x and what is y? So for that we need more information. So you can give more information using these commands. Okay, so title will print the title of the graph. Okay, whatever the title of the graph you want to print. So is this the title of the entire graph? Okay, so the title of the graph is plot of V versus T, and since it is text, so you can see it is within the single quotation mark. Okay, and before we give the single quotation mark, we are giving what? We are giving the normal bracket. Okay, so title the normal bracket, and then within brackets we have single quotation mark and whatever we want to type. Then we can use the X label and the Y label to give the title for each axis. Okay, so title for the entire graph and title for each axis. And the last statement for putting the grid lines. Okay, if you see this one, you only see the axis, right? You don't see the grid lines, intermediate vertical and horizontal lines. Here you can see them. Clear? So you can see the grid lines using the grid command. Okay, now you can see here, in all these commands we did not mention which graph we are talking about, right? Okay, did anybody try one of these commands? Any one of them? You tried, right? It's working and makes the changes to the same graph, right? So the graph must be already plotted and then these commands come. Okay, if you don't want to see the graph before you do all the commands, then what do we do? So when you did this, it plotted the graph, right? And now it is making the changes. So let's say you want to make all the changes and then you want to just see the last picture. What do you do? How do you do that? We just use one simple thing after every command, and the graph will only appear once. Which one is that? Comma? No. Dash? What dash? You did a command in MATLAB, but you don't want to see the answer right now. What do we do? I told you in the last lecture, today as well I started with that. I do a equals to 4, but I don't want to see it again. So what do I do? Nobody knows, right? Exam next week. Okay, go and search. Okay, you want to use different colors and symbols and line types, so you can see the different strings or the commands which are used for colors and so on. Okay, so for each color, okay, B, G, R and so on and so forth, okay, the name of the color and the command which you will use in MATLAB, and the symbol. Okay, symbol is for the points, so each point should look like what? Each point should look like a point or a circle or a square or a cross or what? Okay, you see here, this graph is made up of points, right? There are points here which are joined by the line. Okay, so right now each point is a point, so when you join it you don't see the points, right? But I want to see each and every point, then I can select it that show each point along the line as a circle, so each point will show like this and so on. Yeah, what type of line you want? You want a solid line, continuous line, a dotted line, okay, a dash dot line or a dash line? Solid line, dotted line, dash line, dash dot. Okay, so what type of line you want? So all of them are for working with the graph. Okay, so how do we use it? You can so the default line is a solid line, a thin solid line which is blue in color. This is the default. Okay, if you want to change it, then you will use the functions which are given in this diagram, in this table. with the plot command. Okay, so you can see T and V I was already using it, right? Then I am also putting a small O, okay, and within single quotation mark. Okay, now O is for what? Circle. So each point will show like a circle. Okay, then you can see here quotation mark, again T and V, then quotation mark, S, then two dashes, then G, and then quotation mark close. What will it do? S means what? S means what? Where is S? There is somewhere S here, right? S is here. So each point will show like a square. Okay. Then there were two dashes. Where are the two dashes? So the line will be dashed line. Okay. Points square, line dashed, and the color G. G meaning green. Okay. So whatever you want to change about the line and the point and the symbol and everything, you will mention the axis, the x-axis and the y-axis, then comma, then quotation mark, single quotation mark, and then you use whatever symbols you want. You can pick the color, then you can pick the type of symbol and the type of line and so on and so forth. Now you can see here the order is not important. The order is not important. You can even just do T and V as well. We did T and V, right? Plot T and V. That's it. So it will plot it by default. Default color, default line, default symbol. But if you want to use it, then use it. Okay. The only thing here is they should be in quotation marks. Okay. And you have to use the command from here. Okay. The code from here. It cannot be outside this table. Okay, clear? And I already showed you if you want to put the title of the axis, the grid line, the title of the chart, and so on. Okay, you can also control the line width, okay, as well as the size of the marker and the interior colors and so on. Okay, so for example, we want to use a heavier line, a bold line. Okay, default is a thin line, single point line. Okay, single point is 0.3 millimeter, something like this. So I want to make it bold. Okay, and I want to use the color cyan. Okay, and I want to make the diamond shape markers. Okay, and the edges should be black, and the face, meaning the inside color, should be magenta, and so on and so forth. Okay, so all the fashion sense coming into play here. So again, plot. In the plot, the first thing is always x-axis, y-axis. Okay, then you put a comma, and then you single quotation mark. So two dashes means type of line is dashed. D means, where is D now? Where is it? Yeah, diamond. Okay, symbol is diamond. Okay, and then the color is C. C is for, what do you call this? What color is this? Cyan, right? Okay, so the color is cyan. I don't know what you call it in Arabic. Okay, this is the normal things, right? We already discussed them. and then you are changing the line width. Okay, so use single quotation again. Line width is a command, so you cannot change it. You have to write it as it is. So line width command, and then dot 2. 2 means the width of the line will be equal to 2 points. If you make it 3, 3 points, 4, 4 points, and so on and so forth. Okay, and then and so on and so forth. Okay, now 3 dots will do what? I told you. When you put 3 dots at the end of the line, it will do what? It will continue the next line. Okay, the 3 dots are just showing, okay, go to the next line and read again. Continue. So 3 dot doesn't mean anything here. 3 dot is not a command. It's just telling the program go to the next line. Okay, so next line I am giving what? Marker size. Again, marker size is a command. You cannot change it. Size of the symbol. What is the size of symbol? 10. Okay. Then again, marker edge color. Marker edge color is a command. What is the color? K. What is K? Black is K. No, it's unfair, right? Black should be P. It's K. Okay. Then again, 3 dots means go to the next line. Keep reading. Marker face color. Okay, the inside color of the marker. And again, M. M means magenta. It makes sense, right? M is magenta. Okay. So, and so on. Okay. Whenever you use the plot command, it will delete the previous plot. By default, it will delete the previous plot and it will create a new plot. But before we go there, try this with the T and V data and see the graph, see the changes in graph. Okay, so before the break, we plotted the same graph and we were using different commands, right? Okay, on the same graph. Whenever we use a new command, the previous settings of the graph, they go away. Clear? So you put a title of the axis. Okay, on the axis, x-axis and y-axis, you put a title. Okay, and then you use this command. Now what will happen? The previous properties, the title and the color and grid lines, everything will be gone. You can see it in this graph. Do you see the grid lines and the title or the axis title? You don't see it, because when you did this, everything which you did before this, gone. Okay, now I plotted a graph. I don't want to destroy it. I just want to add new features. In the same graph, I want to add new features. Then we can use a command which is called as hold on and hold off. Okay, so you plotted a graph. Okay, now you want, on the same graph, you want to do something more. So use a command of hold on, then do the other things. Okay, clear? And once you finish, use the command hold off. So everything you will do after hold off will start from new. Okay, let us look at an example. If you do the first example, okay, we already did it. So when you do the plotting for the first time, okay, it will plot T and V using default color, default line, and everything is default. Okay, but then you do T, V and O. Okay, O will change the symbol. So when you use the second command, everything which was in the first graph, it is gone. Okay, so let's say in the first command you change the line color or the line size, anything which you change, when you use the second one, it will be gone. The graph will be plotted again using everything default. Okay. Now if you want to, so in this case the final plot will only display symbols, no line, nothing. Okay. If you use hold on and hold off, which you can see in the second set, so what will happen when you do plot TV? It will draw a blue line, and the default is blue line. Okay. And then you do hold on, and then you do T, V and O. Now O is a symbol, right? So because of hold on, you can still see the line and the symbol as well. In the first case, you will only see the symbol, line will be gone. Got it? So with hold on, any changes will be made on the existing plot. Without hold on, MATLAB will generate a completely new plot and then just apply the changes which you are doing. Got it? In some cases, we can divide the graph into more than 2 axes. Okay, and then we use a command which is subplot M and P. Okay, so M and P will divide the graph window into a matrix of M by N. So that matrix will have M rows and N columns. It's not numbers, huh? The window is divided into. So for example, if I say subplot 2, 2. So 2, means 2 rows, 2 columns. How many boxes total? 4 boxes, right? So now you can have 4 subplots. Got it? Okay. And then the final plot will be on the P axis. The final one is the P axis. So we can use subplot to make 3-dimensional graphs. Okay. So you have subplot is something else. 3-dimensional. This is for 3-dimensional graph. You can use the command plot 3. Plot 3 will divide the graph into 3 dimensions, x, y and z. So now you can plot 3 axes. Okay. Okay. So let's say we have a 2-dimensional graph of x and y. Okay. A graph which has x-axis, and on the y-axis I have sine of t, and the graph graph between sine and cos. Graph between sine and cos. So sine is what? X is what? Sine of t. On the x-axis I will plot sine of t, on the y-axis I will plot cos of t. You already have t, right? Variable t you already have. Okay. So we can employ the subplot command, so we can subsequently add the 3-dimensional plot here. Okay. So what we will do, first of all, we will create another variable t, because t is now the angle, right? T is now the angle. Now can someone tell me what the first command will do? T equals this. What it will do? Tell me. What does it mean? T equals 0 colon P upon 50 colon 10 into P. No. I'm not plotting it, right? Did I start plotting? Did I use a command plot here? No. So it has nothing to do with the plot yet. Okay, I did not start plotting. I'm just doing what? Tell me. I'm generating the value of t. What is the first value of t? 0. What is the last value of t? 10 pi. And between them, it will generate values with an interval of pi by 50. Okay, so first value 0, next value pi by 50, next value 2 pi by 50, next value 3 pi by 50, and so on and so forth until you reach what? Pi 10. Okay, now we will plot it. Okay, so you can see we are using the subplot command, right? Subplot 1 to 1, 1 to 1, row 1 row, columns 2 columns. So how many graphs total? 1 row 2 columns. How many graphs? 2 graphs, right? In 1 row it will plot 2 graphs, one in one column, one in the other column. Okay, and now we are talking about the first one. Okay, so then it will plot sine. Now you can see here, so we gave this command subplot semicolon, so nothing will happen. If you don't give the semicolon, the window will pop up. Okay, then the next command is plot sine of t, cos of t. Which one on the x-axis? Sine is on the x-axis and cos is on the y-axis. Now you can see one more thing here. Instead of writing variable names or numbers here, we can directly do the function. Sine and cos is the function, right? Okay, so we are directly doing the function. Now who will tell me the units of t here? We take sine and cos of angle, right? Sine and cos are taken for angles. And what are the units of angles? Angles can be in 2 units. Which one? Radians and degrees. Which one is this? Radian. Okay, so keep this in mind. Same thing that which we had with Excel, right? Angles are in radians. Okay, then we are using the command axis square, and then we are giving the title. Okay, so let's see. Okay, you can try it and see what you see in your graphs. Okay, so the axis square command will create an axis around your graph. For people who already did this, you can see the graph window is showing a small graph on the left hand side, and there is a space on the right hand side for another graph, right? Okay. So a circle is created because of the axis. Okay, the circle is because of the numbers. So now we want to add something on the right hand side. We already have a graph. Now we want to add something on the right hand side. So you can see now we are creating a variable sine of t in x, cos of t in y, and z equals to t. Okay. Now keep in mind, so x will be one value or multiple values? When you say x equals cos of t or sine of t, x is one value or multiple values? Why one? T is one value? Multiple values, right? If you have 100 values of t, then there are 100 values of x. Clear? If you have 100 values of t, then 100 values of y. Okay. So if you are using a function on a vector, the result is also a vector. Okay. Clear? Okay. So then we go for the subplot. Now subplot, you see the same command. 1, 2. 1, 2 is again, you have one line, one row, and 2 columns. And now then we are saying what? 1, 2, 2. So In the previous one I was doing, see, subplot 1 comma 2 comma 1. Now here I am doing 1 comma 2 comma 2. So it will plot on the other side now. Got it? And what do you want to plot? Plot 3. Plot 3 will make a 3-dimensional graph, x, y, z. Okay? So sine of t is x, cos of t is y, and t is the z axis. Okay? And then you put it as the title. Title is graph number B. Clear? Huh? So we are using two commands together, subplot and plot 3. Plot 3 will create a 3-dimensional graph, and subplot divides the graph window into multiple boxes, and in each box you can make a new graph. This is what it would look like. Okay, graph number A, graph number B, and you can see the title A and B, they are on top of the graph by default. The title of the graph goes on the top by default. If you want to make it more interesting, you can put the axis titles as well. We already saw the syntax for putting the axis titles. Okay, so you don't know what is on the x-axis, what is on the y-axis, right? So you can put for example, on graph A, x-axis is what? X-axis is sine of t, and the y-axis is cos of t. And in the second graph, x-axis sine of t, y-axis cos of t, and the z-axis is t. Okay, so you can add these axis titles using the commands we already discussed. Okay, so you may have seen I was using the help command. Okay, so help command can give you the information about a particular function. Okay, so with help command you should know the name of the function. Okay, so I'm looking for explanation of sine. Okay, so I already know the sine function in MATLAB is written by sin. I know that, so I can use the help function. But let's say I want to take a square root, and I don't know how square root function is written in MATLAB. I don't know the letters, I don't know the code. Okay, so then I can use look for. So it will take the word and try to find anything which is related to logarithm. Okay, so with help function you should know the name of the function for which you are looking for. Okay, but with look for function you just need to know the particular word in English. Okay, sine, cosine, okay, square, matrix, for example. Okay, but if your word is more focused, it will give you less results, which is better for you. Okay, so if you just write square in a graph, doing a square of a matrix, taking power, and so on and so forth, everything will come up. Okay, but if you put it matrix square or something like this, that will only give you the option which you are looking for. Okay, so you have to be smart. We already used the elementary function help, right? It was showing us hundreds of functions. So my problem is still the same, right? I'm looking for one function, now I have to look from the list, and the list have 10,000 values. Doesn't help me, right? So you have to be smart with these things. Okay, any questions? MATLAB. Okay, and we already use some commands, right? The functions, all of the functions which we use were command. And I told you MATLAB works like your calculator in a sequential manner. When you enter a command, it will execute it. Okay, and this is the difference between MATLAB and VBA. In VBA, you type the whole program, and until you run it, it will not give you any result, nor it will give you any error. In MATLAB, if I type one command, I push I put enter. If there's an error, it will show me. If there's some calculation, MATLAB will already do it. Okay, and you can see the result. Even if the results are not on the screen, they are in the the memory of the program. They are there. Okay, so it works in sequential manner. An alternative way to do the programming in MATLAB is using the M files. M files are the MATLAB files. Okay, the MATLAB files, the programming files. Okay, so you did a program and you want to send it to me, so I can use it, I can check it. You will save it as the M file. Okay, like for Excel we have what? What is the extension for Excel files? Extension for Excel files. Next exam. Okay. So we call it M file because the extension is .m. Okay. So every software has its own extension. So the M files can be script files or function files. Okay. The M files can be made up of scripts or functions. So a script file is a series of commands which you have done and we have saved it. Any series of functions, any series of commands which you did, all what you did, you can now save it as a M file. Okay, so it will be called as a script file. It is M file, a MATLAB file, but it is a script file because you did everything. Okay, and it's a series of commands. Okay. So if you want to use certain commands again and again, you can save it as M file. You want to send it to someone to check it and so on and so forth, you can save it as M file. Okay. Okay, so you can call the file. So once you have saved the file, okay, how to save the file? You can see the tab here. You go to the home tab, you go to new option, and then you have the option to save the script file. Okay, they are there. Home tab, new, script file. Okay, so you can save it as this. Okay, or you can simply do Control N. Okay, so it will save the file as a script file. Clear? So this is now a new script file because I clicked on new, right? So this is a new script file. I told you the big window in the middle. In your case, it is a small window in the end. So that is a command window. When you open a new file, it will be opened as an editor window. So if you are only using the command window until now, when you open the new script file, if you do Control N, it will open a new window as well. On top of the window, you will see the word editor. Okay, clear? So for example, we want to create a script file for the same guy who is tying his foot to the wire and trying to do bungee jumping or suicide or whatever. We already did this, right? We already have the commands. So first of all, we'll open a new file. Open a new file, a new script file. After opening the new script file, You will do the commands as they are written. Open a new script file. You can do Control N, or you can go to Home, New and Script. Okay, so you perform these commands, then you save the file as example. Save the file as example. Save and put the name of the file as example. .m will come automatically because this is the extension of MATLAB. Any MATLAB file you save, it will be saved with the extension of .m. Okay. Remember, we are talking about the editor file, the new file you created as the editor window. I'm not talking about the command window. So once you save the file, you can even close it. Don't close the whole MATLAB. Just close the window of the editor. Okay. Then you can go to the command window again and just type the name of the file. What is the name of the file? Example. So when you type example and you enter, it will do everything which you did in the example file. So we just calculated V, right? And what else did we do? We also assigned the values for G and M and T and CD. So when you go to the command window, after saving the file, you go to the command window and you type example and you enter, it will generate all these variables and calculate the value of V. Okay, it will generate variables M and CD and everything. It will assign their values and it will also give you the value of V. Clear? So you can, if you want to save your commands, if you want to save your work, first of all open a new script file, type in that file, then you save that file with a name, and the name would have an extension M. By default it should have an extension M. Okay. Once you do this, then at that time or after 2 days or after 100 years, if you are alive by then, inshallah, and we are still using MATLAB, then you open your command window and you type the name of the file and you click enter. It will do everything which you did in that file. We created a very simple file, right? Only one equation. But if you do 100 equations, it will do all those 100 equations. Clear? So there is no limit. There is no limit of what you can do in one file. In the previous, all the previous calculations which we did today, you can save them all in one file, and it will do all those things when you call the file. Okay. So calling the file very easy, right? Just type the name. Just type the name. Now you have to be careful about the name, like we said for VBA and other things, right? So I cannot use the name sign, SIN. I cannot use it, right? The sign is already a function. Clear? So while you are using the name of a file, try to use a name which is unique, not already used by MATLAB or you. So you create a new file and you save it again with example. The old file will be gone. Okay. So every time you have to come up with a new name. And another thing is, where the file is saved, you can see the current directory here, right? On the left hand side, the file is saved in this folder, and this is a folder. Usually when you installed MATLAB, it already created a folder in your C drive. So by default everything is saved there. If you want to change it, no problem. If you want to see where it's saved, just look at the window there. Clear? Okay. Other type of file is a function file. you can create a function file as well. We created a function in Excel, right? We also created a function in Excel, huh? And now today we just used some function from MATLAB. We use the sine function, the plot function, the subplot function, the log, the length, all these functions. So a function file will do what? It will help you to create your own function. Okay, you can create your own function and MATLAB, and this is why MATLAB, and there are many other languages which are very popular. The popular languages for engineering people and other people who are supposed to do things on their own. Okay, so the popular languages are MATLAB is popular, Excel is very commonly used, we have R, we have Python. Okay, so why these languages are popular? Because you can use them for anything which you want. They are not okay, you can only do this and this and this. No, I want to do more, go ahead. Okay, and I want to do more, but I don't want to do it again and again. Every time I have to do the same problem, I have to do the whole programming again. No, they are giving you an option, save it as a function. And the good thing is, once you grow up, once you guys grow up, then you will find that there are many people. Even now, you can go to the MATLAB company website. They call, what's the name of the company? Anybody knows? It's called MathWorks. Okay, MathWorks. When you went to the portal, it was showing MathWorks. If you go to their website, they have discussion boards. Okay, so somebody like you, not me, definitely, I'll not do it. Somebody like you created their own function. You know what they do? What do they do? They upload it. Upload the M file. So that bungee jumping guy. Okay, so you create a function for that guy. Okay, you want to do suicide? Okay, I will give you a function. Okay, so they upload it. So now I'm looking for the same problem. I just go to their discussion board or blog or whatever, and download the file, run it. Clear? It becomes very easy. Okay, so now you understand why we create function files. Okay, so again you go to home tab and new, and then you see the name function here. Okay, you can create a new function file. So a function file can take input when it is called. Okay, for a script file, everything must be within the file. You have a script file, right? So the value of G and the M and CD and T, everything was in the script file, right? Everything was within the file. But when you create a function file, if you remember when we did it in Excel, so when you will call the function will ask me to give it an input, right? So input is changeable. Okay, so for example, you have the function sine. So when you use the function sine, when you start typing sine, within bracket it will ask you, give me any value of the angle, right? The value is not fixed. If you save it as a script file, it will only run the value which is in the file. When you save it as a function file, when you call it, it will ask you at that time. So you created file now and you want to run it after 2 days. After 2 days it will ask you for a new input. Okay, so this is the main thing here. So you create a function file. Okay, and the function file, the function is this. Okay, this is the main idea of the function. You may not be able to see it. Okay, so the function file should start after you open the function file. You will see these things. Okay, you cannot see it clearly. Let me write it on the board, but it's there on in the slide. It will have function. It's a word. the calling word, the main word, keyword. It will not change. Okay. Then you will write the input values. Okay, which values the program should ask as input within the brackets. Okay, so the first bracket is to give the input values. They call it input arguments. Okay, so for example, x1, x2, x3, all of them are what? Input. So whenever you will use this function, the program will ask for how many inputs? 3. Okay, equals to the output. So now then you will have the name of the function which you want to choose. Now you can choose your own name. Okay, so let's say my function. Again, the name should be unique. You cannot say sine and log. Okay, so my function. Then whatever you write here will become the name of the file. Now you can see here in the slide the name of the file is untitled, so they write here untitled, but you can save the file with a name, and that name should be here as well. Okay, then in the bracket I will give the output values, the output variables, output arguments. Okay, so for example, y1, y2, y3. Okay, so what this function will do, it will take 3 inputs and it will give me how many outputs? 3 outputs. What is the name of the function? Whatever you give here, whatever you write here, it's the name of the function. If I want to use it in MATLAB, I will use this name. I'll use this name, and in the bracket, so I will write it like this: my function, in the bracket what? What values in the bracket? What are the inputs? x1, x2, x3. Okay, x1, x2, x3. Okay, and once you press enter, then it will come like this. We know, right? By default it will be saved in ANS, and then it will give me y1, y2, y3. Got it? Okay, there or not? Everybody? Okay, so then within the function do anything which you want, but make sure the function is calculating. Okay, sorry, this is the output and this is the input. Sorry for that. Okay, output will come before, the input will come after. Okay, so make sure in your function you are calculating y1, y2 and y3 using x1, x2, x3 and by any means. Okay, now for example, somebody takes your function and he wants to use it. Okay, now you created the function, right? So if he wants to ask, he should ask you, not MATLAB. So it should come to your house, pay you 20 PD, right? 20 is enough? You want more? More? 20 is enough, right? Okay, but he doesn't have to do that, right? You can create comments within the function. Okay, so comments are to help him, statements to explain. So how to give a comment with a percentage sign. It should start with a percentage sign. So any line which starts with a percentage sign, and whatever you type after this, it's considered as a comment. Whatever you write, okay, and it is shown with green color. You can see here, shows with green color. And as you have been typing the commands, now you can see when you type something wrong, it shows in different color. When you type something correct, shows in different color. Okay, so the comments are shown in green color. So if you are typing a command and it is showing in green color, it's a problem, right? There's a problem. Okay, so a percentage sign at the start of the line makes it a comment. Okay, without the percentage sign, you can do calculations or whatever. So after you finish the function, then you will. Did you open the file? Function file is appearing, and is appearing or not in the end? Okay. So once you open the file, some of these things are already there. Clear? So for example, let us create a function which will give me the value of v, okay, and the value of v is created using x. So you already opened the file, right? Function file, everybody opened. Now you do this. Okay, so function output is v. So after function in bracket you put v equals the name of the function. What is the name of the function? F. And then within the bracket of f you will write x. X is x. Okay, where is the value of x? Inside the function. Okay, we will use the value of x inside the function, and anybody who is using the function will give the new value of x every time he uses the function. Okay, so the name of the function is f. It will take x and give me v. And what is v? 2 into x minus 1. 2 into x minus 1. After you do this, you save the file, and then you can go to the command window and type the name of the function f. And you can see that it will ask you for the input and it will give you the output. After you make a function file and you type whatever you wanted to do in the function, then you can go to save and save the file. Okay, it will be again saved with the .m extension. Okay, and like I said, you have to make sure that you are in the same folder which is opened as a current folder in your the file is in the same folder which is opened as a current folder in MATLAB. Okay. So there is already a folder named MATLAB in your C drive. Okay, what we prefer to do usually, we keep the current folder the MATLAB folder. You can search where is MATLAB folder in your computer, and just for once and all, you just select that folder as the current folder. The .m files are not so heavy. Okay, the .m files are not heavy. They are just text files, so they are very, very light. So one folder is enough, and you can create subfolders in the main folder. You can create subfolder in the main folder. The main folder is MATLAB. In that you want to save files, you can create folders within MATLAB. Okay, and save the files there. I think it will still work. Okay, prepare a function file which will take the values to compute the velocity again for the jumping guy. Okay, so the function will take the value of M, T and CD, and it will give me the value of V. Okay, so now open a new function file. Open a new function file. You can go with her. Amal, you can sit with someone, because your function file will not work, right? You're using online, right? You can sit with someone for this task, and later on try to install it, okay, on your PCs. Like I said, in the exam is, I will not allow online. So the input values are M, T and CD. What about G? What about G? 9.81. It's not an input, right? We will just write in the equation 9.81. That's it. Okay. So what is your input? M, T and CD. And what is your output? V. Okay. So create a function file which will take M, T and CD, and it will give me the output V. Okay. You can name the function whatever you want. F, double F, F plus, F minus, my F. Comments. So anybody who takes this function from you, you can see all the comments. And somebody, okay, one more thing. So somebody wants to use this function, okay, so he will type help and ask for the function. Okay, so when the MATLAB will open the file, he can see the comments, okay, and he knows what is T, what is G, and so on. Okay, so this is the only thing. We already did it. Okay, now you can see here. Yeah, okay, now pay attention. When you use the function, so you did the name of the function, bracket, the 3 values, and you clicked on enter, right? The value of V was assigned to what? The default. Default is this name, right? So whatever is the output of the function, it is going where? In ANS. What is the name of the output for the program? ANS. Now I don't want to store it in ANS. When the program or the function gives me the output, I want it to store it as V. Okay, so I will write V equals the function. Free fall is the name of the function. For you it is F or double F or double U or whatever. Okay, so you can use it like this then. So the output of the function will be stored in V. Now how many outputs I have? How many outputs I have? 1. So V is one value. If the function is giving you 100 outputs, V is 100 values. Clear? Okay, so like I was saying, function can return more than one value. Okay, and you can see the example over here. Output is only X, and input is only X, and the output are 2, not 2 values, 2 variables, because we know X can be multiple values, right? X can be a vector, X can be a matrix. Okay, so X doesn't mean it's a single value, X means a single variable, and the output are 2 variables. Each one of them can be multiple values. They are not here in this example. Each one of them is a single value, but we know they can be multiple. Okay, so this function, what is the name of the function? Tell me. Stats. How many inputs it will ask for? 1. 1 meaning the input variable is 1. Okay, it will not be one value. because the function will calculate standard deviation and mean. So you cannot calculate mean of one value, right? So x is not one value, it is one variable. It's a matrix. It's a vector or a matrix, okay, which has multiple values. Got it? Okay. For calculating mean and the standard deviation, these are the equations. Okay. N equals length of x. What does it mean? What is the answer of n? Length function or the length command does what? It will count how many values are in x. So if x has 12 values, n is 12. Okay. Then for mean we have a function for mean, right? For mean we have a function. We don't have to calculate mean. For mean we have a function, mean of x. Simple. See it here. Okay. So mean of x or sum of x. You can use mean of x, no problem. We saw there the function for mean, right? In the lecture before the slide, before the break, there's a function to calculate mean. You can use it directly, no problem. Okay. So there's a function for mean, but they are doing what? Sum of x upon n, which is also mean, right? Sum of x upon n is also mean. Okay. So mean and standard deviation has this equation. We use it in Excel as well. In Excel we already used it. So this is the equation for standard deviation, and the answer will be stored in STDEV. Okay, clear? So then what is missing here? What is missing? Do I want to calculate anything more? No, right? So I should have and there should be an end here. Okay, but it's already there in the file, right? When you open the new file, it's already there. So you will save the file. Okay. Now how will you run it? Tell me. Somebody gave you this function and now you want to use it. How will you, what do you do in the command window? But before this, before running the save, okay, save what then? Save the file, right? Save the function file. But now you want to run it. It's already saved and everything. That's it. Let's start typing. Will it work? Will it work? If your first command is the name of the file, it will not work. Why? It will ask you for what? When you want to run this function, it will ask you for what is the input? What is the input? X, right? So where is X? So in the, when you want to run the file, you already have to define X. Now why I am saying define X? Why not just put a number? Because X is not a number. X is a matrix. So if you say stats bracket 2, average of 2 is what? 2. It will not calculate average. Okay. The standard deviation of 2 is what? Nothing. Okay. So because now X is a matrix, so first of all, before you call this function, store some values in X. And how to store the values in matrix, we already learned about it. Okay. Clear? So the functions which you were doing up till now, they were all asking for single values, so you can put a value inside the bracket, no problem. But when the function is asking for a matrix, my suggestion is there are ways by which you can put the values in the bracket itself. But my suggestion is do it before calling the function. Define X or put values in X before you start using the function. It is much better, less confusing. Clear? See? Okay, so we already defined a variable y. So y is what? Input. So now when I will use the program, I will say stats bracket y. Y. What did I write here? Stats bracket y or x? X. And now here stats bracket y, and it is still working. Still working, right? Program is working. Program works because it's not done by me. Okay, so it works. So now important point to keep in mind, the name is not important. Name of the variable not important. Name of the function is important. So somebody instead of stats, somebody writes STATE, it will not work. So the name of the function is important. You cannot change it. And what I tell you about case sensitiveness, it is case sensitive. So stats, small letters must be small letters, right? The name of the function, you cannot change it. Done? Within bracket, what you are writing within bracket, name is not important. Okay, number is important. Number is important and the type is important. Number and type is important. Okay, so instead of x in bracket, if you use y or a or b, or you put the numbers yourself, done, no problem, it will work. It will work. Okay, until and unless it will work if the number of variables are the same and the type of variable is also the same which you are using in the function. Got it? So I was using how many variables in the function? Only one, x. And x is a vector or a matrix. Now if you are using it in the program, then again I should use one variable with the stats, and that one variable should be a vector or a matrix. Now if you call this one variable as x or y or fula or deem, it will work. Okay, clear? So the name of the function is important. It will be as it is, letter by letter, but the inside the brackets, number is important, how many, and the type is important. Clear? Okay, and same thing for the output as well. Output is for this function, how many outputs? 2, right? And each one of them is what? Each one of them is a single number, right? Each one of them is a single number. So m is a single number and s is a single number. Got it? Clear? The function is taking how many variables? 1, and that one variable is a matrix. The function is giving me how many variables? 2, and each one of them is a single value. Now you can see here they are assigning both the values in a single statement. Okay, so m and s are assigned to the outputs of the function are assigned to m and s. Okay, now which one of them is mean and which one of them is a standard deviation? M is mean and S is standard deviation, right? Okay, how do I know this? Because if you look at the function, the bracket of the function, the square bracket, the first value is mean, second value is standard deviation. So the order is important then. Okay, so what did we learn? The values inside the bracket, name is not important. What is important? How many, what type, and in what order. Okay, so the previous functions which you did with the v value, you were asking for 3 inputs, right? T, N, M, C, D. Okay, so again their order is important. So in the function you wrote, ask for T and then CD and then M, and when you are writing in the program, you are putting the value of m first, so it will not work. It will work, but it will not work the way you want. Okay, so the values which are inside the bracket, the inputs and the outputs, there are three things important about them. What did I say? Name is not important. Name of the function is not inside the bracket. I am saying what is inside the bracket. Type, the order, and what else? First thing, you forgot the first thing. What type of variable is it, in what order it is, and instead of m and s, if I instead of y, if I write y comma z comma a comma b, will it work? Will it work? Your program will work. Our program doesn't. Here, if I write y comma c comma d, will it work? No. So what is the third thing which is important? Number of variables. Number. Okay. Type is important. Order is important. Number is important. Got it or not? Okay. In many cases, if you define the wrong type in the program, function may still work, but it will not give you the correct value. Clear or not? So if instead of, if you swap it, program will still work, but the mean will be stored in S and the standard deviation will be stored in M. Okay. So function is working, you will be happy. Doctor, the function is working, but the values are wrong, and you will not know. Okay. So these are the things you have to check yourself. How many variables I will input and how many variables I will take output. What is the type of each variable? Okay, and what is their order? Clear? That's why we use the comments in the function. This is the reason we use comments in the function. Clear? Any questions?